In this video we are going to discuss about second step of simulation, and it is a finite element meshing, that how we can build a mesh that will give us a reliable simulation result. So let's first get some information about what is finite element mesh. That it is about discretization or subdivision of CAD geometry into the smaller object, and which we call it elements, and those elements are connected together at the corner location, and which we call it as a nodes. In short, mesh is a continuous collection of elements that represent a part. The important thing is to build a mesh, that how we can create a good quality mesh and evenly distributed mesh, so we can get a reliable simulation result. We also have to make sure that we do not have any drastic change into the element size, because it will lead us a wrong result. And the people who are doing structure analysis and doing a stress analysis, so they know that discontinuity lead higher stress during those area. So we need a good distributed mesh around those areas. So how we can define local mesh? So Simcenter has a tool that can help us to create a good quality mesh, and we can define a local mesh density. So what we are doing a meshing in Simcenter is directly associated with our CAD geometry. Basically, there is a different type of element available to describe the physical behavior of part, that we can use a 1D element to describe a beam structure. So without building or designing the beam explicitly, we have just need to add those property into the 1D element to represent the beam structure, and we can perform a simulation. If we are doing a simulation of thin wall structure, so in this case we can use 2D cell elements such as analysis of cars, door, roof and hood. The people who are doing or dealing with bulky structure, they can use a 3D solid type of element. The important thing is that what we are doing mesh is directly associated with our CAD geometry. If there is some change later on in our master part or idealized part, the mesh will automatically update. And what we define our local mesh density is directly associated with geometry. So if there is some change later on in geometry, it will automatically conserve. So in demonstration 2, we will mesh this idealized part which I have created for a simulation purpose, and different type of mesh tool available in Simcenter can help us to get this fully mesh part, and we will create our FEM model. Let's start the demonstration 2, that how we can mesh our idealized part. So for that we have to create new FEM modeling and simulation file, where I will keep Simcenter Nastran as my default solver, and here we have different type of analysis such as structural analysis, thermal analysis. We can perform acoustic and vibroacoustic type of analysis. We can also do the rotordynamic analysis. So in our case we are going to perform a structural analysis, so let's select it, and software will create FEM modeling and simulation file for that. So it is also suggesting us to create a solution. We will see this portion into the next demonstration, so let's skip this portion for now. So here you can see that right now we are in FEM modeling environment, where we have different type of tool that can help us to mesh our CAD geometry and prepare our FEM model. So here you can see that this hierarchical structure explain that this is our original CAD part, this is our idealized part, this is FEM model which contain the information about mesh and material property, and this is our main simulation file. So let's create a 3D mesh to this aluminum cover, and I'm going to apply automatic element size. That software will suggest most possible element size as per our selection, and it is about 14.6 millimeter. It also has an option for mesh quality. We also have a different type of settings such as surface mesh and volume mesh. We can also clean up our model. That in our case, I want to keep minimum element length less than or equal to 1 millimeter. So this value is look good for me in my case. So let's generate a mesh as per defined mesh parameter. So software will generate a mesh as per we defined. So generated mesh is look good because we don't have any drastic change into the element size, but the created mesh is look coarse for me. So I need to redefine the mesh size or element size about 10 millimeter, and let's regenerate the mesh. So the defined mesh is or defined element size look good for me, that we have the evenly distributed mesh throughout the CAD geometry. So as we visualize in detail, that you can see that here throughout the thickness we only have one element, which lead us to the wrong result or bad quality result. So at least we need minimum 2 elements throughout the thickness to get good FEA result. So here we have an option. So by selecting the option minimum 2 element throughout the thickness, let's regenerate a mesh, and as per our selection, the software will identify the thickness and apply minimum 2 element throughout the thickness available in our part. So here it generated 2 row of element throughout the thickness. Same way here you can see that it identify the thickness and apply minimum 2 element. So software is smart enough to identify the thickness. So what if we need to control mesh, or we required a local control of mesh? So Simcenter has a tool, mesh control, that by using that we can define the mesh density, that I need the evenly distributed element throughout this circular portion and this circular portion. So I want a particular number of element through this edge, this edge, this edge, this one and that one. The one of the interesting thing is that what we are selecting is not only the elements, it is selection based on our polygon geometry. So it is directly associated with polygon geometry. If there is some change later on, the defined mesh density will automatically update. So let's switch on our elements or mesh, and I need about 64 of element throughout this circular edge, and hit apply. Same way I need the evenly distributed element throughout this circular portion. So let's select this edge and that one, and I need about 48 of elements, and let's define our mesh control to those area, and it's look we need to update something. So by updating our mesh model, our definition will define and regenerate the mesh. So here you can see that now we have an evenly distributed uh, mesh throughout this both circular area. So as we move forward, we haven't applied a material to our FEM model. So let's apply a aluminum material to the solid. So here we have two options, that if we applied material or define material in our NXCAD model, so it will automatically inherit it to our FEM model. You can also create a material as per your requirement. So if you know the property of material, in our case we require mechanical property of material, so we have to define the Young modules of elasticity. We have to define Poisson ratio. If someone is dealing with a thermal problem, they have to define the specific heat, thermal conductivity and thermal expansion coefficient, so they can define material property as per the type of analysis. So in our case we are going to select default material available in library. You can also use a material from a custom library if you are using a customized material, so you can select as per your requirement, but in our case we are using a material from default material library, and we are going to apply aluminum 2040 material to the FEM model, and we can right away apply a material to our FEM model. In following video, we will discuss the third step of simulation, and it is load and boundary condition, that how we can define load and constraint that are associated with our CAD geometry.